Hi again, this is Andy, K4GKP, and welcome back to the Ham Whisperer and lesson 20 in the general class Operator Element 3 exam course. In this lesson we go over the G5A questions. The G5A questions cover resistance, reactance, inductance, capacitance, impedance, and impedance matching. What is impedance? Well, impedance is the opposition to the flow of current in an AC circuit. And impedance is actually an overarching kind of category of things that oppose the flow of current, such as resistance and reactance. They're all kinds of forms of impedance. However, for the exam, the definition is very similar to that of resistance that we already know. So the key to this answer on the exam, though, is you have to associate it with AC circuits. So for the purposes of the exam, impedance is the opposition to the flow of current in an AC circuit. What is reactance? Well, reactance is the opposition to the flow of alternating current caused by capacitance or inductance. And the two things you need to take away from this answer are the alternating current and capacitance and inductance. So reactance is caused by the capacitor's electric field or the inductor's magnetic field. And when the direction of the current flow switches back and forth, like in an AC current or an AC circuit, these magnetic and electric fields will resist the flow, at least temporarily, when the switch is back and forth. So reactance is basically the way capacitors and inductors react to alternating current. Which of the following causes opposition to the flow of alternating current in an inductor? The answer is reactance. And remember the last question when I talked about when you think about reactance, think about alternating current, inductors, and capacitors. And in this case, this is called inductive reactance because it involves an inductor. So essentially, reactance is the opposition to alternating current caused by an inductor or capacitor. So alternating current, inductors, capacitors, think reactance. Which of the following causes opposition to the flow of alternating current in a capacitor? And once again, just like the last couple questions, this is reactance. So when you think alternating current and inductors and capacitors, think reactance. So in this case, because there's a capacitor, it's called capacitive reactance, but that's not important for the exam. Just remember alternating current with inductors and capacitors, that's reactance. How does a coil react to alternating current? The way it reacts is as the frequency of the applied alternating current increases, the reactance increases. So there's a direct relationship. As one increases, the other increases. And remember, this is just for coils or inductors. The way an inductor reacts to increased AC frequency is that the inductor's opposition to the AC current flow also increases. So as the frequency of the applied AC increases, the reactance increases when dealing with inductors or coils. How does a capacitor react to alternating current? Well, it's kind of the opposite of the way an inductor reacts, is that as the frequency of the applied alternating current increases, the reactance decreases. So this is just the opposite. As the AC frequency increases, the capacitor's opposition to the alternating current flow or reactance decreases. So the higher the frequency of the AC, the lower the reactance in a capacitor. What happens when the impedance of an electrical load is equal to the internal impedance of the power source? The answer is the source can deliver maximum power to the load. So if you think back to the standing wave ratio and impedance matching between antennas and transmitters, this is the same thing except a much broader scope because impedance matching doesn't only include antennas and transmitters. When impedances match, the maximum power is delivered, and that's kind of the theme you need to remember for these impedance matching questions. When you match, the closer the impedance is to a match between the power source and the load, the more power is delivered. Why is impedance matching important? The answer is so the source can deliver maximum power to the load. And here's that theme again. And it's the same idea as the last question. Impedance matching deals with power delivery. And when impedance is matched, maximum power is delivered. So impedance matching is important because the source can deliver maximum power to the load. What unit is used to measure reactance? The answer is the ohm, same as resistance. The ohm is used as a unit of measure for pretty much everything that describes the opposition to the flow of electrical current. So reactance is one of those things. The unit of measure is the ohm. What unit is used to measure impedance? Same thing, ohm. Impedance, reactance, and resistance all use the ohm. So when in doubt on opposition to current flow, go with the ohm. Why should core saturation of a conventional impedance matching transformer be avoided? The answer is harmonics and distortion could result. So some inductors have cores, and the purpose of the core is to keep a magnetic field as internal to the coil as possible. So these cores have limits to the strength of the magnetic field they can contain before the field exceeds the bounds of the inductor, or basically the inductor loses control of the magnetic field. So reaching this limit is called core saturation. Now exceeding this limit, or core saturation, can cause the transformer to send out harmonics, which can cause a lot of interference. And it can also damage your transformer circuit if you're not careful. So the end result is that harmonics and distortion could be produced by this core saturation. So core saturation of a conventional impedance matching transformer should be avoided because harmonics and distortion could result. What is one reason to use an impedance matching transformer? Once again, when you're matching impedance, you want to maximize the transfer of power. And this is the impedance matching theme of the day. Think big picture on this. Impedance matching doesn't always have to do with antennas and SWR. You're also looking for the best answer on this one. So the best general answer for this question is the one reason to use an impedance matching transformer is to maximize the transfer of power. And that goes for all various categories of impedance matching. Which of the following devices can be used for impedance matching at radio frequencies? And this is an all of the above question. The answers are a transformer, a pi network, and a length of transmission line. And the length of transmission line of the pi network you may be familiar with antenna matching, but the transformer has to be able to match impedance. A pi network is basically a combination of inductors and capacitors put together in a way that is designed to match impedances. And all these items basically help match impedances. Which of the following describes one method of impedance matching between two AC circuits? And the answer is insert an LC network. And as we talked a little bit about in the previous question, LC networks are circuits where you use capacitors and inductors to control impedance. And the pi network that we mentioned in the previous question is a type of LC circuit. LC network. So it's important to remember that when you see LC, you think inductors and capacitors, because this will recur again and again. And it's generally used as a type of impedance matching system. So an LC network is what you would insert between two circuits, two AC circuits, to match impedances. And it's time for the G5A quiz. So take out a piece of paper and a pencil and number 1 through 14. When you're done with the quiz, you can stop by hamwhisper.com and check your answers. They're under the exam answers page. So I'm going to be going through the questions pretty quickly, so if you need more time, just pause the video and take all the time you need. And let's get started with the quiz. Question 1. What is impedance? A. The electric charge stored by a capacitor. B. The inverse of resistance. C. The opposition to the flow of current in an AC circuit. Or D. The force of repulsion between two similar electric fields. Question 2. What is reactance? A. Opposition to the flow of direct current caused by resistance. B. Opposition to the flow of alternating current caused by capacitance or inductance. C. A property of ideal resistors in AC circuits. Or D. A large spark produced at switch contacts when an inductor is de-energized. Question 3. Which of the following causes opposition to the flow of alternating current in an inductor? A. Conductance. B. Reluctance. C. Admittance. Or D. Reactance. Question 4. Which of the following causes opposition to the flow of alternating current in a capacitor? A. Conductance. B. Reluctance. C. Reactance. Or D. Admittance. Question 5. How does a coil react to AC? A. As the frequency of the applied AC increases, the reactance decreases. B. As the amplitude of the applied AC increases, the reactance increases. C. As the amplitude of the applied AC increases, the reactance decreases. Or D. As the frequency of the applied AC increases, the reactance increases. Question 6. How does a capacitor react to AC? A, as the frequency of the applied AC increases, the reactance decreases. B, as the frequency of the applied AC increases, the reactance increases. C, as the amplitude of the applied AC increases, the reactance increases. Or D, as the amplitude of the applied AC increases, the reactance decreases. Question 7. What happens when the impedance of an electrical load is equal to the internal impedance of the power source? A, the source delivers minimum power to the load. B, the electrical load is shorted. C, no current can flow through the circuit. Or D, the source can deliver maximum power to the load. Question 8. Why is impedance matching important? A, so the source can deliver maximum power to the load. B, so the load can draw minimum power from the source. C, to ensure that there is less resistance than reactance in the circuit. Or D, to ensure that the resistance and reactance in a circuit are equal. Question 9. What unit is used to measure reactance? A, farad. B, ohm. C, ampere. Or D, Siemens. Question 10. What unit is used to measure impedance? A, volt. B, ohm. C, ampere. Or D, watt. Question 11. Why should saturation of a conventional impedance matching transformer be avoided? A, harmonics and distortion could result. B, magnetic flux would increase the frequency. C, RF susceptance would increase. Or D, temporary changes of the core permeability could result. Question 12. What is one reason to use an impedance matching transformer? A, to reduce power dissipation in the transmitter. B, to maximize the transfer of power. C, to minimize SWR at the antenna. Or D, to minimize SWR in the transmission line. Question 13. Which of the following devices can be used for impedance matching at radio frequencies? A, a transformer. B, a pi network. C, a length of transmission line. Or D, all of these choices are correct. And question 14. Which of the following describes one method of impedance matching between two AC circuits? A, insert an LC network between the two circuits. B, reduce the power output of the first circuit. C, increase the power output of the first circuit. Or D, insert a circulator between the two circuits. And that's the end of the quiz in lesson 20. For the answers to the quiz, go to hamwhisper.com. You'll find them under the exam answers page. Just look for the G5A section of questions. And until next time in lesson 21, this is Andy, KE4GKP, saying 73, and I hope to hear you on the air soon.